All right. So my name is Suby Raman, and I am a software engineer at Duo Security, based out of Michigan in the United States. And we have been doing some of the earliest product-based exploration of the Web Authentication API. You heard a bit about that yesterday in Christian's talk. In a few weeks, we'll be rolling this out to our millions of users who depend on us for access to their applications. A little bit about Duo, if you haven't really heard about us, but I just want to give an overview of what I'll be talking about today. I'll first be talking about why we care about WebAuthn, why you might want to care about WebAuthn, coming up with a development plan for it. When we started developing for it, it was very early. It was still a draft. It was only supported on Firefox. A lot of stuff changed really rapidly. The design challenges of WebAuthn, because this is sort of a new usability paradigm for authentication that we have to think about. And looking ahead at what we see the future of WebAuthn and where we see it being used. A little bit about Duo, if you haven't really heard of us, one of our core products is providing two-factor authentication. You've heard a lot of great words about 2FA, so I don't have to really explain it. After some sort of primary authentication process, a user is presented with a prompt that looks like this, where they can provide a secondary factor, like a push notification, a phone call, a passcode. We've heard words about the relative shortcomings of some of these factors, so I don't have to mention them, but it's one of the reasons why we are indeed excited about WebAuthn. And as a company, a large part of our business is trying to make security a little less scary by helping organizations deal with some of the inherent shortcomings of passwords. I think it's somewhat easy to fall into the trap of blaming users for some of these problems. Like, why can't the dumb users just remember random passwords? Why are they reusing passwords? Why are they losing their passwords? The developers, we're so dumb. Why can't we just be smarter about handling passwords in general? I think this is the wrong instinct. For me, this whole process ultimately boils down to empathy, where we blame our users for some of the inherent usability problems of passwords. It's kind of a pointless exercise to me. The human brain was really not meant to deal with all the various complexities of authentication. Wendy Nather is really cool. She works at Duo. So what is WebAuthn? Christian gave some good background on this yesterday, but it allows us to authenticate our users using public key cryptography. At a high level, for example, this is what registration looks like. A server during registration says, hey, if you want to register, send me a public key. An authenticator like Touch ID, Windows Hello, YubiKey generates a new private public key pair. The private key stays on secure hardware, and the public key is sent to the server along with a credential ID that is used to refer to the credential key pair later on. And this is what it looks like on the front end. As mentioned yesterday, you had this navigator.credentials.create function. You pass in some configuration there, and a new key pair is created. So during authentication, what happens is the server requests a signature or an assertion that the user indeed owns the private key that they registered with. So we say, hey, sign this data. A signature is created with the private key that they registered with. The signature is presented to the server, and then the public key that was gained during registration is used to verify this signature. And so in this way, the combination of the public and private key is used to authenticate the user. And this is what it looks like on the front end. You have this .get function. You pass in some configuration here, and this creates the signature. So in the context of primary authentication, I feel WebAuthn goes a significant way to mitigate some of the common problems with passwords. For example, passwords being a shared secret. If someone phishing gains access to the password, they are able to impersonate that user. In the case of WebAuthn, only the public key is exposed. An attacker can't do much with the public key. They certainly can't impersonate the user with just that key, because the combination of two keys is used to identify that user. Passwords being hard to create and remember. In this case, the authenticator itself is responsible for creating a random and secure credential key pair. Passwords being easy to steal. In this case, there's secure hardware built into your MacBooks, your iPhones, secure enclaves, trusted platform modules that make credential theft rather difficult. Passwords encouraging unsafe reuse. There is a property of WebAuthn called scoping, where a key pair is scoped to a particular origin, like browser cookies. So it can't be used at origins that impersonate another, which goes a long way to mitigate certain types of phishing attacks. Passwords being hard to secure as developers. Again, the credential public key is not secret. If a database is breached, these public keys are not as attractive as a password is. So how does WebAuthn fit in with our goals? So we were early adopters of U2F, and at Duo, we acknowledged some of the shortcomings that were mentioned with MFA via SMS, phone calls, and push notifications. And U2F was a really, really great early effort to provide phish-resistant MFA. However, there was only early support for Chrome. And the nice thing about WebAuthn is that we see good industry buy-in across browser vendors. You might recognize someone familiar up there. Christian, you're up there. Yeah, we see good signals from Microsoft, from Google, from Mozilla. Hopefully we'll get some good public signals from Apple in the next few months. There's a general seeming consensus that WebAuthn is a good path forward. A major perk for me is, so we haven't heard much about the accessibility of passwords. Some of our users who are mobility or memory impaired may have certain problems with passwords, remembering them, producing them, whereas a biometric authenticator, they might have a more positive experience because, a biometric is a representation of who they are. It's just a perk. WebAuthn is not inherently connected to a biometric authenticator. It's just something that can provide a more frictionless authentication event. Another big reason I'm excited is the benefits for developers. Even at some of the smartest companies in the world with great security engineers, all it takes is a single misconfigured piece of software lurking in the massive software architecture, and plain text passwords are exposed. And I guess if they can't get password-based authentication right, what hope do normal people have? So building a plan to integrate WebAuthn and how we went about doing it. The first was thinking about development, and I should say that a lot of my work involves JavaScript development. I do a lot of UI development. I Google image search JavaScript developer and came up with that picture, so that's apparently what we all look like. I'm also a music major, and we recently caught a lot of shit because the Equifax CISO was in fact a music major. But there was a great response from people in the security community saying like, hey, it's not that she was a music major. There were a ton of other problems at Equifax. It was an empathetic response that made me feel really good. So I should say my first experience with programming, this is relevant, I promise, was looking at this. This is Hello World in Java. And my initial response to this was to be quite intimidated. Because there's about like 10 things here that are kind of aside to the task of like telling the computer to print Hello World. You have stuff like package management, like access specifiers, like type theory, and if you get one of these things wrong, the Java compiler yells at you, and it's really scary. So my response was basically to sort of say, like, okay, programming is super hard, I'm never going to learn it. I basically quit for like 5 years until I encountered the same thing in Python, which was very approachable, very nice. I'm not trying to get into a language war. I definitely really appreciate Java now. But as a beginner, this was something I could understand and not be intimidated by. Now, with WebAuthn, as mentioned, a developer's first experience will likely be engaging with this function here, where you create a credential. And what happens is they get back this, an object containing really large, scary words, like attestation. A lot of binary data that they can't really examine. And the binary data thing is actually going to intimidate people because JavaScript developers never deal with binary data. We deal with arrays, maps, strings, and so on. And this is going to be a little bit scary. It's important to be empathetic to this point. I know as security professionals, you live in the binary world, but a lot of other developers do not. I was particularly fortunate at Duo that I had a research team that I could lean on that was already doing some really, really cool work with WebAuthn, and most people will not. I'll come back to this point a little later. But breaking down how we went about working with WebAuthn in general, if you look at the spec, you'll see diagrams like this. The spec is very thorough. There's a ton of detail, but again, that makes it a little intimidating. This is called the attestation object. It contains a bunch of nested data, byte strings you have to slice, data that is encoded in CBOR, and so on. Importantly, it contains the credential public key, which is right there, used to authenticate the user. It's pretty complex to understand just looking at it, and when we started, I didn't have much reference code to look at to figure out how to actually parse this out myself. My strategy was basically to draw it out, sketch it out, noting all the types of all the data, how the data is nested. Importantly, something complicated with WebAuthn is that you have different branch points where the data can look different. And I should say that these initial design stages really paid off later when it was time to extend the code. Going through this exercise, if you are working with this or any other complex data structure, might be worthwhile. If you are going to think about working with WebAuthn, it might be a good idea to use some type of extensible library for processing data, for type coercion, for validation, because you'll find that each data member that you get back has a validation sequence associated with it. It might help you keep track of all the work you have to do, make your code extensible for future editions. For example, Golang has some really cool libraries out there for declaring objects and declaring validation sequences associated with them. Duo Labs has some code examples out there written in Go and Python that I definitely suggest you check out if you want to see reference code using WebAuthn. Being really careful in each step to be sure that you're following the spirit of the specification is really important. The specification outlines a 19-point procedure to verify the data you get back, and then there's branching data to verify the attestation data you get back. I'll talk about that a little later as well. But because there's not really full-featured libraries out there for parsing WebAuthn data, it might be incumbent on you to do this work yourself. So my recommendation, if you want to start working with a particular authenticator, is to start with Chrome's Touch ID implementation, actually, which just dropped a few weeks ago in Chrome 70. The reason is that it is built into the user's device, and there's existing usability patterns that a user is familiar with. Everyone knows you take your finger, you press it down there, and it works. Whereas, with a YubiKey, with an NFC key, that might be less true. There's also a relatively simple data verification process because the attestation data you get back is a little less complex. And Google did a really good job visually indicating to users exactly what is happening here. You see you have the Touch ID prompt pop up. The user confirms it after they put their fingerprint in, and they have now created a credential. So designing around this. So we had existing design work that incorporated U2F tokens. Like Google, Duo is a member of the FIDO Alliance. We have a lot of users that are very enthusiastic about U2F tokens, which is great. However, WebAuthn expands this, and an interesting challenge we had was, what do we even call this thing? Because you have security keys, which are something you have in your hand and you plug it in. You have Touch ID, which has an entirely different usage pattern than a security key. Windows Hello also has a different usage pattern, which has a facial recognition thing. So even communicating to users what the procedure will be was an interesting thought experiment, because it's not really that great to say, like, hey, something is going to happen, do it. It could be like a facial recognition, it could be like a Touch ID thing. You really want to guide your users to a positive first impression. So another thing was that I think as a security community, we've done a pretty good job indicating to users that a second factor is not on your computer. That is to say, you're probably going to pull out your phone, you're going to answer a text message, you're going to answer a push message or something else, but it's not on the same computer. Whereas today, we have entirely separate hardware on your computer that's capable of securely serving as a second factor. So there's another interesting, design communication challenge here that users will have to be socialized into. So from a design perspective, again, there was the article people have talked about where passwords are effectively synonymous in our users' minds with security. Passwords are everywhere, and the transition away from passwords, if it happens, is going to be a really significant shift in the way we think about what makes a website secure. So as of today, there are a number of browser implementation differences. For example, Windows Hello can be the Microsoft Biometric Authenticator, can be accessed with Microsoft Edge. In the future, it'll likely be able to be accessed by Chrome and Firefox. Chrome has a Touch ID implementation that is only accessible on Chrome. And there's also various differences in, say, like what browser can access NFC Bluetooth authenticators. And Safari doesn't support WebAuthn at all right now. So developers can't exactly expect a completely even experience now, though the hope and trajectory is that things are improving here. So again, at Duo, we really wanted to guide users to, the option and the procedure that made sense for their browser. Like they'd see a security key option on a WebAuthn compatible browser. They would see a Touch ID option on a compatible browser. So we decided to build a sort of decision engine to help guide users, like to show Windows Hello if they have the right OS and browser, to show Touch ID if they have the right OS browser and browser version. This requires a lot of stuff like user agent parsing and like using the WebAuthn API to determine if there's a platform authenticator available. This is because we really wanted to make the user experience as friendly as possible. Some websites might not do this. Some of the foreseen and unforeseen challenges that we saw. So for many developers, again, the concept of public key cryptography in and of itself is going to be very new and scary, let alone the mathematics of it. Like, I don't understand this at all. Like, some of you do. Like, this is another language to me. But you do need to have, like, a passing familiarity with some of it. Like, you need to know the components that make up an elliptic curve public key. You have to know that it has, like, an x-coordinate, a y-coordinate, a curve type. You have to know how to use this data. There's also a lot of new concepts in the WebAuthn spec. Some of these might be even new to the security community. For example, CBOR, which is like a way to pack binary data like an advanced JSON decoder, is used extensively in the WebAuthn spec. But also there's this syntax called COS, which is a concise way to represent a public key. Which uses integers to represent all of the metadata and so on associated with a public key. For example, this indicates that the public key type is elliptic curve. This indicates that the signature algorithm is ES256. The curve type here, the x-coordinate, and the y-coordinate, and you need all of this information to verify, a signature. This adds a bit to the cognitive burden of normal developers. There was a trade-off being made here because a lot of authenticators are going to be low-powered, operating over low bandwidth channels like NFC and Bluetooth, so they wanted to pack the data as tightly as possible with the trade-off of human readability. It's worth mentioning the sheer breadth of the spec. With U2F, there was one signature algorithm you had to concern yourself with, which is ES256, basically. With WebAuthn, there are potentially dozens, which is cool from a security perspective, right? You can deprecate, older algorithms. You can introduce new algorithms, which is cool. However, as an engineer, it means that we now have to account for, quite a bit more code surface and testing surface and maintainability surface, which is something to consider. The spec itself does give the option to say, like, hey, I only want to accept this algorithm and this algorithm, but at the same time, like, if you don't support, certain algorithms, your users will probably complain. Another thing worth mentioning is attestation. Attestation is a way to cryptographically prove that a key pair did come from secure hardware. You can do this to prove that a key pair didn't come from like a fraudulent source or like a paste bin somewhere. The WebAuthn spec provides, as of this date, 6 different attestation formats, 6 different ways that this data can be provided. This is often in the form of some type of certificate that is burned into the authenticator during manufacture time, and you get back a signature that you verify. I want to talk about TPM attestation, which is the attestation that comes with Windows Hello. The spec links to a document that looks like this. It is a 166-page document that was clearly written for embedded programmers. It has like lots of information about C structs, clearly not meant for mortal programmers like myself. And my response was to be like, maybe I should just give up. I'm never going to understand this. But luckily, 2 engineers at FIDO, Adam Powers and Yuri Ackerman, spent 2 weeks living in this document, drawing arrows between everything until they finally got to the point where they could actually like parse this data. So it's an interesting point in time where the spec is pretty young. and the knowledge to do everything required by the spec is still getting out there. But I'm pretty confident that we will get there eventually. So something particular to Duo is that our auth prompt takes place, or it uses an iframe. The party integrating us, instantiates an iframe, which loads the Duo auth prompt. However, the WebAuthn spec explicitly forbids any type of interaction inside of an iframe, which is understandable. They wanted to avoid something called origin confusion, where a user might authenticate to an origin they don't expect to. So our workaround for now is to provide some type of pop-up which has the effective origin of Duo inside of the pop-up, and the user can authenticate there. It's not a perfect solution, but it's a workaround that we had for now, and we're working on a better solution. Most of you won't encounter this problem, but at the same time, there might be some gotchas you might encounter when dealing with the spec. Another thing worth considering is that there is a fear of biometric authenticators everywhere, and we've found that consistently. A lot of this is unwarranted. It comes from Hollywood, people afraid that their fingerprints or faces are going to be stolen. But some of it is justified, like this case where an Android phone was found to be storing fingerprint data in an insecure way. The spec does provide a way to whitelist authenticators, to be safe. Like you can provide a list of something called an AAGUID, which is like a global identifier for an authenticator. But the spec allows them the option not to, because certain low-powered authenticators might not have the ability to provide certificates or attestation data. So developers are in now somewhat of an awkward position where we would like to avoid a lot of potentially irresponsibly made authenticators, but we don't have the information to really do so at this point. Rolling this out to users, the nice thing about WebAuthn, again, is that you can log everything. You don't really have to worry about exposing private data like you would have to be with passwords. The data you get back from the authenticator isn't terribly useful in identifying a user. You don't have those same concerns. A general suggestion I have is that you can incrementally add support for browsers, for attestation types, for signature algorithms, for cross-platform authenticators versus platform authenticators. But that I mean a cross-platform authenticator is like a YubiKey, platform authenticators like Touch ID. The reason being is you'll probably find certain usability problems, certain code problems as you do so. Looking ahead, I do want to be clear, even though with all of the implementation challenges we found with WebAuthn, it nonetheless provides a really clear path forward to really, fish-proof authentication, which is very exciting. This is an example of our integration with Windows Hello. It recognizes my face, which logs me in. Really cool stuff. But given the educational challenges, I did want to make an effort to help introduce WebAuthn to web developers in a non-intimidating way. So I've partnered with other folks at Duo to produce this guide, which will be available soon. WebAuthn.guide, appropriately named. It'll have a lot of background information about public key cryptography in a very non-judgmental way, because a lot of developers won't know too much about stuff like public key cryptography. The end goal is to hopefully make this entire space a lot more approachable and friendly. It'll provide code samples, information about how to engage with each attribute for configuring WebAuthn, the reasoning behind everything, and so on. So stay tuned for that. We hope to release it in the next week or so. So in conclusion, I know we've seen people toss around this prediction and haha, it is pretty silly that he predicted that in 2004. But at the same time, I do want to caution people about making bold predictions the other way. The internet was still pretty young in 2004, and public key cryptography was still pretty cumbersome. A lot of the implementation challenges are being increasingly met here, and all I ask here is that we do keep an open mind. Without being dramatic, for some people, the loss of a password can be the difference between life and death. And if we can move the needle to the point that 80% of breaches have to adapt or die, I think we've done some good, and that's worth keeping an open mind for. So that is it for me. Please reach out to me with any questions, and stay tuned for the release of this guide. And I believe we have some time for questions.